In this lesson, I'll show you how to solve a nonlinear system with its variables in the denominator. The question reads, solve the nonlinear system of equations shown below. Notice that the variables for both of these equations are located in the denominator position, and because of that, it's not a linear system. It is a system, however, with two curves intersecting at one point. Because the variables are in the denominator position, it makes this question slightly more complicated, because normally with linear equations, the variable is in the numerator, and we can simply use one of the methods, either addition, subtraction, or substitution, to quickly find the solution. So what we have to do to both of these equations is multiply them by their common denominator, which will convert these equations so that the variables are in the numerator position, making it easier to solve. Let me show you how to find the common denominator for both of these equations. I'm going to start by labeling this equation 1 and this equation 2, just for clarity's sake. To find the lowest common denominator, or even a common denominator for equation 1, you start with the numbers of the denominator. So we have the number 3 and 5. Let's find out the lowest common multiple of 3 and 5. So we have 3, 6, 9, 12, and 15. And for 5 we have 5, 10, 15, 20. Notice that the number 15 is common in both of these sets, and it's actually the lowest common multiple of these two sets. We also have this x and y to deal with. All we do with those is multiply them together. So x times y is xy. Combining this 15, we get 15xy. This is the lowest common denominator. We'll do the same thing for number 2. Start with 4 and 3. The multiples of 4 are 8, 12, and multiples of 3 are 6, 9, and 12. Notice that 12 is common in both of these sets. Similarly, x times y is xy, giving us the LCD, the lowest common denominator, of 12xy. Now, if you don't want to find the lowest common denominator and you just want to find a common denominator, all you do is multiply the two denominators together. So 3x times 5y would have given you 15xy right away. Sometimes, however, if you do that, you'll get a number that's larger, and so you'll have to work with two equations with larger numbers. Once you found your lowest common denominator for both, you'll multiply this equation by its lowest common denominator. So multiply that by 15xy and multiply this by 12xy. If I multiply this whole equation by 15xy, I have to multiply each of these terms by 15xy. So I'll show you how that works for the first one. We'll multiply this by 2 over 3x, multiply this by 3 over 5y, and multiply this by 17. Don't forget the equals and plus. Let's see what happens. 15xy times 2 is 30xy, divided by 3x is 10y. And you can also picture it with this x at the top and this x at the bottom canceling out. Similarly, 15xy times 3 is 45xy, divided by 5y gives us 9x. And 15xy times 17, well, 15 times 17 is 255xy. So this equation has now been converted to this equation, and mathematically they mean the same thing. Let's multiply 12xy to 3 over 4x. 12xy times 3 is 36. Divided by 4x gives us 9y. 12xy times 2 is 24xy. Divided by 3y gives us 8x. And 12xy times 19 gives us 228xy. The next step is to use either addition-subtraction method or substitution to find out your x and y coordinates. Unfortunately, however, none of the coefficients are the same for us to right away add or subtract, so we have to choose one of these variables to eliminate, and it doesn't matter which one you choose first. I'm going to choose to eliminate y. If I choose to eliminate y, I need to make this 10 and this 9 somehow the same. And I can do that by multiplying this whole equation by 9 and multiplying this whole equation by 10. Look what happens. 9 times 10 is 90y. 9 times 9 is 81x. And 9 times 255, for that I'll use my calculator. 9 times 255 gives me 2,295. Don't forget the xy. It's a common mistake. 10 times 9 is 90. Look, the coefficients are the same now. 10 times 8 is 80x. And 10 times 228 is 2,280xy. Now I can subtract the two equations, because if I subtract them, the y's go away, the y terms. This becomes 0. 81 minus 80 is 1x. And 2,295 xy minus 2,280, that gives us 15xy. You'll notice that in the left side of this equation and the right side of this equation, both have an x. So if I divided both sides by x, I would end up eliminating one of the x's. So I'll cross this out with this, leaving me with 1 is equal to 15y. All I have to do is divide both sides by 15, giving me 1 over 15 is equal to y. So my y coordinate for this point of intersection is 1 over 15. Now I have the option of placing this 1 over 15 into this equation, this equation, this equation, that equation, or even any of the two original equations. You want to choose the easiest equation just so that you don't make a mistake. And this looks like the easiest of the 6 to work with. So I'm going to rewrite this. 9y plus 8x is equal to 228xy. And I'll substitute my y coordinate, which I just found to be 1 over 15, into here and into here. 9 times 1 over 15 plus 8x, 228x times 1 over 15. I'm going to evaluate this now in my calculator. Should give me 3 over 5. So this is 3 over 5. That stays the same. And 228 times 1 over 15, or 228 divided by 15, that gives us 76 over 5. Now we collect like terms. This term and this term are alike. Bring that over. If I bring it over, I end up with 76 over 5x minus 8x. 3 over 5 stays on the left side. This number minus 8. Remember, we're only working with the coefficients. So minus with 8, we get 36 over 5x. And remember, the whole goal was to find out what our x coordinate was. So this time we isolate for x by dividing both sides by 36 over 5. That cancels this out, leaving us with this quotient over this quotient on the left side. 3 over 5 divided by 36 over 5. This gives us 1 over 12. Therefore, a point of intersection is at 1 over 12 and 1 over 15 for this nonlinear system of equations. And there you have it. That is how to solve a nonlinear system with its variables in the denominator.